Hi students, welcome to our YouTube channel Knowledge Academy. The main aim of this lecture is to discuss about the differential equations formulas of mathematics in a very detailed manner. So these formulas will be very much useful for the examination of the GATE and also IES and also some of the state examinations also. So now we are going to learn about the differential equations. The first one is called as the order. See, order of a differential equation is the order of highest derivative appearing in differential equations. See, suppose in the equations, if there is a differential equation and if you want to know what is the order of a differential equation, means whichever the derivative which has the highest order, means highest value of derivative, then we are going to call that as the order of a differential equation. See, order of a differential equation is the order of the highest derivative appearing in the differential equation. So out of all the derivatives in the differential equation, so which is having the highest value, that we are going to call it as the order. So order of a differential equation is the order of the highest derivative appearing in the differential equations. So now what is the meaning of degree? So degree of a differential equation is the power of highest derivative in differential equation after the equation has been expressed in form free from radicals and fractions as far as derivatives are concerned. See, degree of a differential equation is whatever the order you are going to get. So that order, you have to take the power of that order. So whatever the power of that order, that we are going to call it as a degree. So always there must not be any fractions. Always it has to be a purely integer. So therefore, if there are some fractions, you have to go for some cross multiplication or some powers in order to make it as a purely integer. So therefore, we can say the degree of a differential equation is the power of highest derivative in differential equation after the equation has been expressed in a form free from radicals, means free from fractions, and fractions as far as derivatives are concerned. So these are the important things of order and degree. So order means nothing but in a differential equation which is going to have the highest derivative, that we are going to call it as the order. But degree means the highest power of any order, the highest power of order of equation, that must be free from fractions. By using some simplifications, we have to make it as a free from fractions. Then whatever the power of order, that we are going to call it as the degree of a differential equations. So order means whichever the thing derivative which has the highest derivative, that we are going to call it as the order of a differential equation. Whereas the degree or power means whatever the power of the highest order, that has to be free from in the fractions only, it has to be a purely integer. By using some simplification, we need to make it as a purely integer, and that power we are going to call it of highest degree or highest order, that we are going to call it as the degree of a differential equation. So now we have learned about the order and the degree of a differential equation. So now we discuss about the linear differential equation. See, linear differential equation means, suppose this is the differential equation of the form. So you can see clearly P1 dn to the power of y by dx to the power of n plus P2 dn to the power of n minus 1 y by dx to the power of n minus 1 means n minus 1 derivative of y with respect to x up to Pn dy by dx plus Pn plus 1 y is equal to x. Here x is called as the function of x, means it is a purely function of x. And now if you see clearly, suppose if I am going to ask what is the order and the degree of this differential equation. See, out of these, the highest derivative is nth derivative, so therefore we are going to call this as the order of n. And if you see carefully, for this highest order, if you take the what is the power of this value, which is equal to 1, so therefore we can say the degree is nothing but 1. So therefore the order is equal to nth degree n, whereas the degree is equal to 1. This is for the nth differential equation, or we are going to call this as the linear differential equation, because here P1, P2 up to Pn plus 1 means all these coefficients and also this x are functions of x only. Means you can see clearly this P1, P2 are Pn and also Pn plus 1 and also x, this capital X, all these are functions of x only. Then only we are going to call this is called as the linear differential equation. So whenever if you see any equation in this format, whenever if you see any differential equation in this format with having always P1, P2 up to Pn plus 1 and comma x are only functions of purely x, then we are going to call this as the linear differential equation. And for this linear differential equation, the order is equal to n and the degree is equal to 1. And now we'll discuss the linear equation with constant coefficients. So now we are going to see the linear differential equation with the constant coefficients. See, it is a special case of the previous one. So same thing we have taken, only thing is we have replaced P1, P2 by some constants, an minus 1 up to a naught y, so is equal to x. So if you see clearly for this differential equation also, if the question if they are asking what is the order, is nothing but n, whereas the degree is equal to 1. So you can see clearly now this all these coefficients are nothing but these are the constant values. These are purely constant values, and this is the x is a function of purely x. So therefore we are going to call this as the linear differential equation with the constant coefficients. It is a special case of the previous equation. X is equal to 0, then it will be linear homogeneous differential equation in the first case and linear homogeneous constant coefficient differential equation in the second case. So you can see clearly here, if x is equal to 0, then it will be linear homogeneous differential equation in the first case and linear homogeneous constant coefficient differential equation in the second case. Means, suppose if this x is equal to 0, it indicates we can easily call this equation as the linear differential equation of homogeneous, or we are going to call it as a linear homogeneous differential equation. And whereas here also if x is equal to 0, then we are going to call this as the linear homogeneous constant coefficient differential equation, which is the only difference. So if x is equal to 0 in this case, we are going to call this equation as the linear homogeneous differential equation, whereas if x is equal to 0 in the second one, then we are going to call this as the linear homogeneous constant coefficient differential equation. The only difference between these two equations is this P1, P2 and Pn and also Pn plus 1 are purely constant values, and here x is a function of purely x. This is the only difference between the linear differential equation and the linear differential equation with the constant coefficient equation. So now we are going to discuss about the first order first degree differential equation. Means the order is of 1 and also degree of 1. So these things now we are going to learn in an easy manner. So how we are going to solve these first order first degree differential equations by different methods now we are going to see. See, the first method is separation of variables. This is the first method, separation of variables. So you can see clearly here dy by dx is equal to f of x comma y. dy by dx is equal to f of x comma y. So you can see clearly for this differential equation the order is 1 and also degree is equal to 1. So for this equation I want to do the separation of variables. Then if you do this simplification, finally you are going to get g1 of x into dx plus g2 of y into dy is equal to 0. Means x terms are with respect to dx and y terms are with respect to dy. Means we can separate the x values and also y values independently, and we are going to get in this manner, which is equal to 0 after doing the simplification of this equation. So integrate it and find the solution. So you have to do the integration with respect to independently, because you have to do integration with respect to x and integration with respect to y is equal to some constant value. So this is the general solution of this differential equation. So therefore this is called as the general solution of this differential equation. So only thing is you can separate x terms and y terms independently and do the integration with respect to x, and also this is for with respect to x and this is for with respect to y and is equal to constant. So this is called as the general equation of this differential equation. This is called as a separation of variables because we can easily separate the x and also y independently. So now we are going to discuss about the homogeneous equation form. This is the second way of solving the first order first degree linear differential equation in a very easy manner. See, now suppose if any differential equation in this format, which is dy by dx is equal to f of x comma y by g of x comma y. So suppose if f of x comma y is nothing but it is in the format of x to the power of n into g1 by g1 of y by x, whereas g of x comma y is in the format of x to the power of n by x to the power of n into g2 into y by x. So therefore x to the power of n and x to the power of n is common, so we are going to cancel off this each other. So therefore we can say this is a function of y by x and this is also function of y by x. So now I am going to assume that y by x is equal to some constant value which is v. So let me assume this is y by x is equal to v. So therefore if I take this x side, this to the right side, I am going to get y is equal to x into v. So now I am going to do the differentiation with respect to x. So therefore dy by dx is equal to this is v plus x into dv by dx by using the uv method. So therefore now I want to replace dy by dx with the help of this equation. So therefore v plus x into dy by dx is equal to, here as I have already told you, f of x comma y I am replaced by this equation, and g of x comma y I replaced with this equation. So x to the power of x to the power 1 cancels. So finally I am going to get g1 with a function of v, because y by x I am going to replace by v, and similarly g2 with a function of v, because here also y by x is nothing but v. So now if you see carefully here, now this is in the format of a separation of variables, means now this new equation will be, you are going to get in the format of the previous one, which is the separation of variables. Now you can easily go for the previous method, and you can do the simplification, and then finally substitute that v is nothing but y by x, and then we are going to get the final solution, which is called as the general solution of this differential equation. So whenever if you see any equation, any differential equation in this format, then it is very much necessary to solve in the method of homogeneous equation form. Then you can use this method to simplify this one, and finally you are going to get the new differential equation in the form of the separation of variables, and you can easily separate x and y and do the integration with respect to x for the x value, and do the integration with respect to y for the y variable is equal to c, and then finally substitute v is equal to y by x and do the simplification. Finally you are going to get the general solution of this differential equation, which is in the format of the homogeneous equation form. Now we are going to see the special case, a special case of this homogeneous equation. Suppose equation reducible to a homogeneous form. Suppose if you see an equation in this format, how to reduce this into a homogeneous form, I am going to discuss now. Suppose if you see any equation, any differential equation in this format, then how to make this in terms of the homogeneous equation, I am going to discuss now. Suppose when a1 by b1 is not equal to a2 by b2, means we can say these two lines are not parallel to each other. See, whenever the a1 by b1 is not equal to a2 by b2, then we can simply say that these two lines are not parallel to each other. Then what we are going to do, how we are going to proceed to do the simplification. Suppose I am going to assume that small x is equal to capital X plus h, and small y is equal to capital Y plus k. I am going to assume in this manner, which is small x is equal to capital X plus small h, and small y is equal to capital Y plus k. I am going to assume in this manner, and then if you do the differentiation with respect to x, so therefore dy by dx is equal to, as h and k are constant values, so therefore we can say dy is equal to d of small y is equal to d of capital Y, because k is a constant value, and similarly dx is equal to d of capital X plus 0, because it is a constant value. So therefore if you do the division, dy by dx is nothing but d capital Y by d capital X. So now I am going to replace dy by dx is equal to d capital Y by dx is equal to, but here I have already told you that is in the previous equation. Now we have to replace small s is equal to capital X plus h, and replace small y by capital Y plus k, and if you do the simplification, finally you are going to get in this format. So now this is the two equations we are going to get finally. These are the two equations we are going to get finally. So now you have to solve these two linear equations, and if you solve these two new equations, then you are going to get the value of h comma k. So at this h comma k, these equations are going to become 0. So therefore this value will become 0, and also this value or this equation will become totally 0 for this particular h comma k. So therefore this whole equation is going to reduce to a small equation, which is dy by dx is equal to a1x plus b1y by a2x plus b2y. So now I am going to take x as a common in this whole things, then I am going to get a1 plus b1 into y by x plus a2 plus b2 into y by x. So now if you can see clearly, this is in the previous format. So now use the previous method procedure to solve this equation. Let me assume capital Y by capital X is equal to v. So therefore capital Y is equal to capital V into x. So therefore now you do the dy by dx. So dy by dx is equal to v plus x into dv by dx. So now I am going to replace this whole thing by this equation. So therefore v plus x into dv by dx is equal to now a1 plus b1v by a2 plus b2v. Now this we can simplify into a separable, linear separable format. So now you can solve this method by the first procedure, which is the separation of variables. So now solve this method. Now solve this like variable separable method, because this is the first method that we have learned. And now after solving this one, we are going to get an expression in the terms of v, but v is nothing but capital Y by capital X, but again capital Y is nothing but small x is equal to capital X plus h, and small y is equal to capital Y plus k. But we want x and y, so therefore capital X is equal to small x minus h, whereas capital Y is equal to small y minus k. So replace that, then finally you are going to get the general solution of this linear homogeneous equation. So this is the way that you have to convert. You have to assume that small x is equal to capital Y plus k and small y is equal to capital Y plus k, whereas suppose small x is equal to capital X plus h and small y is equal to capital Y plus k. And by this method we are going to do the simplification and we are going to get the solution. Suppose now this is second case. Suppose dy by dx is equal to a1 plus x, a1x plus b1y plus c1 by a2x plus b2y plus c2. Suppose when a1 by b1 is equal to a2 by b2, it indicates that these two lines are parallel lines. Then how you are going to, then what is the method you are going to simplify these equations? Then what we have to do is, I am going to assume that a1x plus b1y is equal to z. Then I have to assume that a1x plus b1y is equal to z. Then do the differentiation with respect to x. So you are going to get a1 plus b1 dy by dx is equal to dz by dx. So now only thing that I want is dy by dx. So therefore if you do simplification, we are going to get dy by dx is equal to 1 by b1 into dz by dx minus a1 by b1. So now all these things you have to substitute here or replace here. In place of dy by dx, you are going to get 1 by b1 into dz by dx minus a1 by b1 is equal to, here this is nothing but now it's a function of z and this is also some function of z. So now solve this variable separable method. So this equation now will become in the format of the linear or called as a variable separable method. So by this variable separable method or by the separable method, you can solve it and you are going to get in terms of z, but z is equal to a1 plus a1x plus b1 by, you have to replace, and finally you are going to get the general equation of this differential equation. So I have told you, whenever the two lines are not parallel, you have to go for the first procedure. Whenever the two lines are parallel, you have to go for this second procedure. Means by these two procedure we are going to convert into a homogeneous equation, and then by using the substitution we are going to make it in terms of the variable separable method, and finally we have to replace those values by the actual values, and then we are going to get the general solution. So up to now we have learned about the two methods in order to solve the first order we can say the first order first degree linear differential equation. By using the first method is variable separable method, and also the second method is homogeneous method. So in these two methods, in the second method I have told you two concepts, the concept A and the concept B. So now we are going to learn about the third method. So the third method is called as the Leibniz Form. So now we are going to solve about the Leibniz Form method, which is this is the third way to solve any first order first degree differential equation, which is dy by dx plus by is equal to q. So this is called as the Leibniz form, which is dy by dx plus by is equal to q, where p comma q are the functions of x only. Then solution is, see if you see any first order first degree, because the order is 1 and the degree is 1, so therefore first order first degree differential equation, suppose if it is in the format of dy by dx plus by is equal to q, and also p comma q are the functions of x only, then what is the solution? Then the solution is y into e to the power of integral p dx is equal to integral of e to the power of integration of p dx into q dx plus c. C is a constant. See, this e to the power of integral of p dx we are going to call it as the integration factor. So this we are going to call it as the integration factor. So therefore y into integration factor is equal to integral of integration factor into q into dx plus c. So this is a general solution. So integration factor is equal to e to the power of integral of p into dx, whereas overall solution is equal to overall general equation of this differential equation is equal to y into integral factor is equal to integration of integral factor into q into dx plus c. So this is called as the general solution of this differential equation. We are going to get this one. So now we are going to see some special case of this third method. See, equation reducible to linear form. Suppose there is an equation in this format, which is y dash of y f dash of y into dy by dx plus f of y into p is equal to q. Suppose in this format, if the question is there, then how we are going to convert into Leibniz form we are going to see. See, I am going to assume, f of y is equal to z. If f of y is equal to z, then I am going to do differentiation with respect to y. So therefore, with respect to x, so therefore f dash of y into dy by dx is equal to dz by dx But already we know that is f dash of y into dy by dx is nothing but dz by dx. So I am going to replace this thing by dz by dx plus, but this is f of y is nothing but z. So z into p is equal to q. So you can see clearly here now z and q are functions of x only, but now you can see clearly here p and q are functions of x only. So therefore now this is in terms of the Leibniz form, and by using the Leibniz form method you can solve this differential equation, and finally you can keep the original value, which is z is equal to f of y. So solve this linear equation and convert to that, because this is in the terms of the Leibniz form. So for this Leibniz form, the general solution is y z into, because here now y is replaced by z, so z into integration factor, which is e to the power integral of p dx is equal to integration factor is e to the power integration of p dx into q into dx plus c. So now you got a solution in terms of z, but you have to replace z is equal to f of y in the finally, then you are going to get the original solution of this equation. So now we are going to see the Bernoullis form. This is also a special case of the Leibniz form. So now this is also included in the Leibniz form method. See now, suppose this is the equation. Suppose if the equation in this format, which is dy by dx plus py is equal to y to the power of n into q, where p and q are functions of purely x only. P and q are functions of x only. Suppose if you see any differential equation in this format, then we are going to call it as the Bernoullis equation, or dy by dx plus py is equal to y to the power of n into q. So if you see clearly, it is a first order and the first degree differential equation. So all these methods are only useful for solving the first order and the first degree differential equations. So now what I am going to do is, I am going to divide the previous equation with respect to y to the power of n. So after that I am going to get in this format. So if I do the division with respect to y to the power of n, LHS and RHS, I am going to get in this format. So then what I am going to do is, I am going to assume that 1 by y to the power of n minus 1 is nothing but I am going to assume it as z. So therefore if it goes to the upward, it is going to get y to the power of 1 minus n is equal to z. So now I am going to do the differentiation with respect to x. Then I am going to get 1 minus n into y to the power of n minus 1. So therefore 1 minus n minus 1 is nothing but minus n. So therefore it is going to become downward. So y to the power of n into dy by dx is equal to dz by dx. So now I am going to take this constant to this side. Finally I am going to get 1 by y to the power of n into dy by dx is equal to 1 by 1 minus n into dz by dx. So now we have already know this equation is nothing but we are going to replace this one by this value, which is 1 by 1 minus n into dz by dx plus, but we have already assumed this 1 by y to the power of n minus 1 is nothing but z. So z into p is equal to q. So therefore z into p is equal to q. So now you can see clearly, if you do the rearrangement, so dz by dx plus 1 minus n into z into p is equal to q to the power of q into 1 minus n. So this is in the terms of the Leibniz form. So now you can easily solve this equation, and then we are going to get general solution. In the final general solution, we have to replace z is equal to 1 by y to the power of n minus 1, and then you are going to get the final solution. So now solve this linear equation and convert it to back. Same thing I wanted to. This is in the terms of the Leibniz form. So now by this special case also, this Bernoullis method is also, it is also in the format of the Leibniz form. Only thing is we have to do some simplification. So now we'll discuss the fourth method. See, the fourth method to solve the first order first degree differential equation is the exact form. Suppose if you see any differential equation in this format, which is m of x comma y into dx plus n of x comma y into dy is equal to 0. So now you can see clearly that m is a function of x comma y and n is also a function of x comma y is equal to 0. But if there is no y term for x and there is no x term for this equation, then we can say these are in terms of the purely variable separable. But these are the function of both the variables x and y. That is the reason this we can't use to solve by using the linear separable. But only thing is we can solve by this exact form. So this equation will be exact only if. So this equation will be exact only if dou m by dou y is equal to dou n by dou x. Suppose whatever the equation you are going to get, if this is going to satisfy this equation, which is dou m by dou y is equal to dou n by dou x. If it is, suppose this is with respect to dx, means you have to go with respect to dou y, and this is with respect to dy, means you have to do the partial differentiation with respect to x. So therefore dou n by dou x. So if both are equal, then only we can say this equation is called as the exact form. Otherwise this is not in the terms of the exact form. Then suppose it is going to satisfy, then we are going to call it as the exact equation, and the solution will going to become like, you have to do the integral, you do the integration in the both the sides is equal to some constant value. So here integrate with respect to x, assuming y is a constant. So for this value we have to do the integration with respect to x, treating that y as a constant value. But here what we have to do is, now assume x is equal to 0 here. First thing is we have to assume x is equal to 0. After that you are going to get some equation, and then for that equation, whatever the equation we are going to get after assuming x is equal to 0, that equation we have to do the integration with respect to y only. So listen carefully. Here this, for the first term you have to do the integration with respect to x, treating as y as a constant value. But for the second part, first you have to assume that x is equal to 0. After substituting x is equal to 0, you are going to get some equation. For that equation you have to do the integration with respect to y. Then we are going to get this c is equal to c. So this is the final solution of this exact form. See, if this equation is going to, if this differential equation satisfying this equation, this condition, then only we have to go for this process. Otherwise you don't have to go for this process. See, now we are going to learn about another method, which is first order higher degree differential equation. Suppose if you see any differential equation of first order but of higher degree, then how you are going to use the method to solve this type of equations we are going to see now. Suppose I am going to assume that dy by dx has some p. Suppose if you see carefully, this is a linear differential equation of order 1, but the degree is equal to n. So wherever dy by dx is there, I am going to assume as p. So therefore we can say this is the order of n, or we can say this is called as this is the first order. The order is only 1. Order is only 1, but a degree of n. So therefore this is called as this linear polynomial equation, or we are going to call it as this linear differential equation of order 1, but degree is equal to n. So wherever dy by dx is there, just I am going to substitute p. So therefore this is p to the power of n, p to the power of n minus 1. So you can see wherever dy by dx is there, I have substitute p, then I am going to get this equation. This is nothing but a polynomial equation. This is in terms of polynomial equation. So now you can solve this polynomial equation because it's a degree of n, so therefore you are going to get n equations. So f of p is equal to 0, solve and find all the values of p. So because it is a n, so therefore it is a polynomial of nth degree, so you are going to get n roots. So therefore now find all the values of p, that is p1, p2 up to pn. So therefore exactly n differential equations, solve each and get the exact solution. So exactly n differential equations, solve each and get exact solution. So basically what we are going to get is, so for everything we are going to get, so for everything, as there are n roots, we are going to get n differential equations we are going to get finally. Means n first order, first degree differential equations we are going to get. So now for each and everything we can solve the solutions and we are going to get the overall solution. So now we are going to learn about the another form, which is the Clarion's form. So this is very much important. Here suppose if you see any differential equation in this format, which is y is equal to px plus f of p. So y is equal to px plus f of p means that p is nothing but dy by dx. So if you see any differential equation in this format, which is y is equal to px plus f of p, where p is nothing but dy by dx, means f of p is nothing but polynomial equation in the terms of p, means f of p is nothing but it is a polynomial equation in the format of p, where p is nothing but dy by dx. So for this equation, the general solution is, suppose if you want to know what is the general solution is, the general solution of this equation is equal to y is equal to cx plus f of c, means wherever p is there, just replace p by c, then you are going to get the general solution of this differential equation, which is y is equal to cx plus f of c, where c is called a constant value. In order to figure out the singlet solution, we should follow this below. Treat x comma y as a constant and c as variable and differentiate with respect to c. Suppose here for this one, suppose if you want to know what is the singlet solution, then what you have to do is we have to treat x and y as a variable but c as a constant. So therefore now and differentiate with respect to c, because x and y is a constant but only thing is c is a variable. So now I am going to do the differentiation with respect to c. So therefore I am going to get this is 0 is equal to x plus f dash of c. So therefore 0 is equal to x plus f dash of c, because x and y as a constant value, treating c as a variable. So I am going to get 0 is equal to x plus f dash of c. So now I can get the value of c. So therefore now I can get the value of c and put the c in the above equation. Then we are going to call this as the Singlet solution. So if you want to know the Singlet solution of the general solution, then we have to treat x and y as a constant and do the partial differentiation with respect to c. So therefore 0 is equal to plus f dash of c. So now we are going to get the value of c. Substitute this c in this equation. Then finally you are going to get the Singlet solution. This is called as a Singlet solution. So therefore if you see any equation in the format of y is equal to px plus f of p, this is called as a Clarion's form. So for this, p is called as a dy by dx. The general solution of this Clarion's form is just 3 plus p by c. Then you are going to get the general solution, which is y is equal to cx plus f of c. This is called as a general solution of this equation. So now we are going to learn about the orthogonal trajectory. Suppose if you want to find what is the orthogonal trajectory of any general solutions, how we are going to do that one? The first step is, for the given trajectory, find the dy by dx. So for the given general solution, the first thing is we have to figure out the differential equation. Then by using the dy by dx, so we have to find the dy by dx of this general equation. Then we are going to get some equation dy by dx. For orthogonal trajectory, it has a slope. The slope will be, which is inverse of -1 by the slope of the previous one. So therefore dy by dx of new graph is equal to -1 by dy by dx. So whatever the dy by dx you have got, just you have to go for the -1 by dy by dx. Then you are going to get a new equation. So this is called as the new differential equation. So for this new differential equation, you can use any of the previous methods. See, whatever the methods we have learned, you can choose whichever the method which is very apt to solve this differential equation. You can use that and you can find the general solution that is going to satisfy this differential equation. So that general solution is called as the orthogonal trajectory for the original equation. So therefore integrate and find the general solution. Now all this family of curves are orthogonal to the main curve. So therefore this is the way. First you have to find the dy by dx of the original curve, and then you have to go for the -1 by reverse, and then we are going to get the new differential equation. So solve this new differential equation by any of the previous method. So whatever the family of curves we are going to get by this differential equation, all these things are now orthogonal to the main equation or the main curve. So in this format, now you have to do the procedure in order to figure out the orthogonal trajectory equations. Up to now we have learned so many different methods how to solve a first order first degree and also first order nth degree. So we have learned so many different methods, but now we are going to see some more things, which is nth order linear differential equation with the constant coefficients. So how to solve a nth order linear differential equation with the constant coefficients? We are going to see the different ways how to analyze a nth order linear differential equation with the constant coefficients. Now we are going to see. So you can see clearly this is called as the linear differential equation with the constant coefficients, because all these constants are very constant value. These are the numerical values, some real numbers, whereas this capital X is a function of x. So therefore the highest order is n, whereas the highest degree, for the power of highest order is called as a degree, so therefore its power is 1. So therefore an minus 1 and a1 a0 are called as the constant values, whereas capital X is a function of x only. So now for this, the solution will be, the solution y is nothing but it is the summation of the complementary solution and also particular solution. See, complementary solution means the input is 0, means we are going to assume it is a homogeneous equation. Whenever the input is 0, we are going to assume it is a homogeneous equation, means the solution we are going to call it as the complementary solution. And this is called as a particular integral when the input is going to get present. So therefore whatever the output you are going to get is the summation of the complementary solution and also the particular integral, or we can even call this as the transient solution, and this is called as the steady state solution. So it is always, the output will be always summation of the complementary solution and also particular integral, or it is also called as the transient solution plus the steady state solution. Complementary solution means the input is 0, whereas the particular integral means the input is not equal to 0, or simply we can say this is the output of the homogeneous equation and this is the output of the non-homogeneous equation. Now how to find the complementary function? So how to find the output of this complementary function means the input is 0. So now I am going to replace d by dx is nothing but d. I am going to replace by small d by small d is equal to capital D. So therefore d to the power of dx to the power of n will become now d to the power of n. So Now I am going to assume d by dx as d. So therefore d n to the power of dx to the power of n is nothing but d to the power of n. So now as the input is equal to 0, I am going to assume. So I am going to take d as a y as a constant value. Then I am going to get a function of d. So therefore f of d into y is equal to 0. So you can see clearly now I am going to replace d as some m value. Also I can replace. It is up to you whether you choose d or m. It is up to you. But in this question, in this way, I am going to assume as d I am replacing by m. So f of m into y is equal to 0. So therefore now we can see clearly. See now for these values of m, this equation will become 0. So therefore I want to find what is the values of m for this equation will become 0. Solve f of m is equal to 0 and get the roots. So now solve this f of m is equal to 0. It may be a quadratic equation, it may be a cubic equation, or it may be a simple equation. Solve this equation and get the values of the roots. F of m is equal to 0 and get the roots. Suppose if the roots are real and distinct, means if they are real numbers, means purely real numbers, and also they are not same, then the complementary function solution will be c1 into e to the power of m1x plus c2 into e to the power of m2x plus, and goes on. So therefore here c1 and c2 are constants, and in m1 comma m2 are the roots of this equation. Suppose if the roots are real and equal, then it will become y complementary function is equal to c1 plus c2x plus c3x squared c4x cubed up to c e to the power of m of x. Means suppose if there are two roots, means we have to take only the first two values. If there are three roots, means first you have to take the first three values. If you have four, means you have to take the first four things. So this is called as the general solution of the complementary function solution. If their roots are different and real and distinct, means now ycf is equal to c1 into the power of m1x plus y c2 into the power of m2x. If the roots are real and equal, means you have to go for this process, which is c1 plus c2x plus c3x squared up to e to the power of mx. So whatever the number of roots, only that number of roots you should consider. Suppose the roots are complex conjugate. See, complex conjugate always comes in a pairs. So therefore, if the roots are complex conjugate, means a plus or minus ib. So therefore we can say ICF is nothing but c1 into e to the power of a plus ib into x plus c2 into e to the power of a minus ib into x. So wherever m1 is there, I have substitute a1 plus ib. Wherever m2 is there, I have substitute a minus ib. So if you solve this one, if you solve this equation, finally we are going to get in this format, which is e to the power of ax into capital A into cos bx plus capital B into sin bx. Or sometimes we can write ab as some constant values, because ab are a constant value. So therefore e to the power of ax into a into cos bx plus b into sin bx. So whenever the roots are a plus or minus ib, you can write either in this process. But if you do a simplification, finally you are going to get in this manner, which is e to the power of ax into some constant into cos bx plus some constant into sin of bx. So cos bx plus sin bx, some constant. So therefore we can say these are the roots of this one. So therefore if roots are complex conjugate and equal, suppose these are the complex conjugate and also they are equal, so therefore how you are going to do this one? So therefore now here e to the power of ax, and this is same as the previous one, but there are two roots as a common. So therefore 2 times it's a common. So therefore you have to take the first two pairs, which is c1 plus c2x. So this is the way that you need to analyze this amount of stuff. So now we'll discuss about the particular integral. So up to now we have learned the different ways how to solve a complementary function solution. But now we are going to learn about the particular integral. Means the input is non-zero. Means we can also call it as a non-homogeneous equation. So simple thing is we are going to assume d is equal to d by dx. So d to the power of n is equal to the power of n by dx to the power of n. So now if you take y as a constant, and then we are going to get in this formula, which is f of d into y is equal to x. So yp is equal to x by f of d. So therefore d is called as a differentiation, means 1 by d will become integration. So therefore now suppose if the input is in these formats, so now for different inputs how the solution is going to become, means how the particular integral solution is going to become, now we are going to see. Suppose if capital X is equal to e to the power of ax, then how we are going to find the particular integral solution, which is yp is equal to e to the power of ax by f of d. So the only thing that you have to do is replace d by a, means wherever d is there, just replace d by a. If f of a is not equal to 0, means see here, suppose if you replace d in terms of a, then f of a you are going to get. Suppose if f of a is not equal to 0, then this is the particular integral. Suppose if you got f of a is equal to 0, Suppose if you substitute a here and you got f of a is equal to 0, then what we have to do is just you have to keep a x value here. You have to keep an x value here in front of it and do the derivative of this one, f derivative of d. Then we have to substitute in place of d again a, and this value should not equal to 0. Then this is the answer. So therefore, if f of a is equal to 0, then you have to do this derivative and keep x here and the f dash of d, and here in place of d again replace a. If f dash of a not equal to 0, then this is the solution. But still, suppose if still again you got it is equal to 0, then you have to keep another x, means x squared, and f double dash, means you have to go for another derivative, which is f double dash of d. And if you substitute here, this a is not equal to 0, so therefore only thing is here, just replace in terms of d with respect to a. If f of a is not equal to 0, then this is a solution. If f of a is equal to 0, but f dash of a not equal to 0, means just do keep x here and do the differentiation with respect to d. Suppose if this f dash of a is also equal to 0, then it indicates do the another part, which is x, multiply again x and do the another differentiation. So therefore finally you are going to get x squared by f double dash of d. And this is the way. Suppose still you got again 0, then you have to do the same procedure. Means we are going to get finally x cube f triple dash of d. So you have to use this procedure until you are not going to get any 0. So therefore until the denominator value is not equal to 0, you have to apply this procedure. So therefore we can say this is the way that you have to get the particular integral solution for any equation or any input with the format of e to the power of ax. So now we are going to learn about the another. Suppose if the x is another one, we are going to see now. Suppose x is a function of sine of ax plus b or cos of ax plus b, then how you are going to do get the solution. Suppose if a capital X is equal to the input is sine of ax plus b or cos of ax plus b, then particular integral yp is equal to sine of ax plus b by f of d. But here we have to replace d square by minus a square. In the previous one, whenever e to the power of ax replace d by a, but here replace d square by minus a square. So wherever thing is the d square, just replace d square by minus a square. So now what you have to do is you have to do some simplification in terms of d. We are going to get here g of d square, where replace d square by minus a square. So therefore if minus a square is not equal to 0, suppose still if you got 0, here also suppose if you got 0, then again you have to go for your x and here do the differentiation with respect to d. Then you are going to get this equation. Again you replace d square by minus a square, but still you not get the 0. Suppose if you get the 0 again, you have to go for the another part, which is x square and double dash, g double dash of d square. So you have to follow this procedure until you are not going to get 0 in the denominator. So therefore whenever the sine ax plus b or cos ax plus b, just replace d square by minus a square. If suppose input is a function, is a polynomial function, suppose if x is equal to pk of x, means polynomial of x of highest degree k, then how you are going to do this one? Suppose if x is a polynomial function of highest degree k, then how you are going to get the particular integral solution we are going to learn. See, yp is equal to pk of x by f of d. So therefore now what you have to do is just do the inverse of this one. So therefore f of d over inverse into pk of x. Then I will give you a small basic formula. Use this one for the expansion of the f of d whole to the power of minus 1. See, remember this formula, which is 1 plus x whole to the power of n, which is 1 plus nx plus n into n minus 1 by 2 factorial x square, and goes on, means 1 plus nc1 x plus nc2 x square plus nc3 x cube plus nc4 x to the power of 4. So in this manner you have to do this one. So therefore 1 plus x whole to the power of n is equal to 1 plus nc1 into x plus nc2 into x square plus nc3 into x cube, and goes on. So remember one thing again, 1 plus x whole to the power of n is equal to 1 plus nc1 into x plus 1 plus nc2 into x square plus nc3 x cube, and it goes on. So use this formula for this f of d whole to the power of minus 1. So therefore now you are going to get a function of d equation and use into multiplication of pk of x. Then you are going to get the final solution we are going to get. So therefore finally you are going to get the particular integral solution we are going to get. So this is the thing that you have to go for this process. Suppose if the input is e to the power of ax into v. Suppose if the input is e to the power of ax into v, then how we are going to do the process? So v is a function of anyone which you discuss in the above three cases. So suppose v can be anyone. See, whatever the thing that we have learned up to now, the inputs like polynomial function, sinusoidal function or cosinusoidal function, it can be any value. It can be any value. We can be any function what we have learned in the previous ones. Then what we have to do is here yp is equal to e to the power of ax into v by f of d. See, now I need to take this e to the power of x outside. So therefore, if I take e to the power of x outside, then replace d by d plus a. So therefore, you have to replace d by d plus a. Then you have to go for the separate part of doing the simplification to get the solution. So therefore, if you replace e to the power of x outside means replace d by d plus a. So therefore, now do the whatever the simplification you want to do, just do simplification within the bracket itself. Then you are going to get the overall solution. So for this do analysis which we discussed above. So now you can do, as we know the value of function v, you can use any of the for any of this value which we already know. See, the procedure whatever we know for these different equations we already studied. So use any of these different solution ways only for this within the bracket, then you are going to get the overall solution. So if you want to take e to the power of x outside, just replace d by d plus a. So suppose if the function x is equal to sin of x plus b into pk of x. Already we have learned that pk of x is nothing but it is a polynomial function of degree k. Then how we are going to solve this particular integral output we are going to see. So then I have already told you here sin of x plus b is nothing but we can write which is the imaginary part, which is called as the imaginary part of e to the power of I of x plus b into pk of x plus f of d. So you can write this as the easy manner, which is yp is equal to imaginary part of e to the power of I of x plus b into pk of x by f of d. So you can see clearly now, just you have to take the imaginary part out of doing the simplification. Just you have to take the imaginary part. See how to do the simplification means, now this is in the format of e to the power of x into v by f of d. So therefore now here if you see clearly e to the power of ia x plus b you can write, which is e to the power of ia into b into e to the power of ia x b. So therefore the constant value is e to the power of I b is a constant, so you can take it outside. But here e to the power of ia into x, so if you take out of the bracket you have to replace d by I want to tell d plus a, but here a is nothing but ia, so therefore you have to replace d by d plus ia. So therefore you have to do the simplification and you have to do the equation of this one, and finally wherever the output you are going to get, you have to take only the imaginary part, and that is called as the original solution of this equation. Suppose if the input is cos of x plus b into pk of x, here pk of x is a polynomial function of kth degree, then now we are going to do is yp is equal to, where cos is called as the real part, so real part of e to the power of I of x plus b into pk of x by f of d. So same thing you have to do the following procedure as the previous method, just you have to take this outside, means you have to go for the addition and by d plus ia, and remaining everything is the same as the previous method. So therefore finally you will get the solution, means you have to take only the real part of this overall output, you are going to get the solution for this equation. So now do just copy of analysis as you did in the fourth case. See, whatever the fourth case what we have done, the previous method, same method we have to do adopt here. If you take e to the power of ax outside, just replace d by d plus a. Same method as we did in the fourth case, you have to apply here also. Now we are going to get the exact solution of this for particular integral for these different types of input. So now we have learned the different ways of analyzing in order to get the complementary function solution, and also particular integral solution also we have learned. We are going to learn about another one, which is calculating particular integral using variation of parameters. So now we are going to see the easy way is there is also another method to figure out the particular integral solution by using this method, which is suppose there is a second order first degree differential equation, which is d square y by dx square plus p into dy by dx plus qy is equal to x. Suppose if in this format, now there is also one more method. By using this method also we can figure out the particular integral solution, which is where p, q and x are the functions of x only. Means is capital P, capital Q and capital X are the functions of x only. Then find the complementary function. I have already told you, you have to equate this input as 0, and then you are going to get a complementary function. Because this is the second order, so you are going to get two roots. So therefore the complementary function will become ICF is equal to c1 into e to the power of m1x plus c2 into e to the power of m2x. So I am going to assume this is y1 and this is y2. So therefore y1 is equal to e to the power of m1x and y2 is equal to e to the power of m2x. Then I am going to choose some value w. W is the determinant of y1, y2 y1 dash, y2 dash. I am going to assume in this manner, which is w is equal to determinant of y1, y2, y1 dash, y2 dash. So now the particular integral solution will be in this format, which is particular integral solution is equal to y2 into integration of y1 by w into capital X, means capital X into dx minus y1 into integral of y2 capital X by w into dx. See how to remember this one, I will tell you now. Suppose keep the negative here, negative symbol here, and this is integral, and here now take x dx and x dx by w is also same, then first here y1 y2 y1. See, remember how to, I am telling how to remember this one, which is first take minus here, integral. See, x w capital X into dx by w, capital X into dx by w. Here y1 y2 y1. So this is the way that you have to remember in order to get the particular integral. So if you don't even remember this formula also, still you can go for the previous method. But suppose if you have a function x which is not, suppose if the value of, if the function x is not in the previous any of the 4 inputs, then definitely this procedure will help you to find the solution. So now we will discuss another thing, which is equations which can be reduced to the earlier concepts. Suppose if there is an equation and you can do the reduction in order to get the previous values, the previous concepts, whatever the concepts that you have learned, we can reduce this type of equation to the previous concepts and we can easily solve. Suppose if you see a differential equation in this format, which is an into x to the power of n into d to the power of n by dx power of n plus some constant into same power, same degree. If this order is n, means the degree is also xn. If it is n minus 1, means n minus 1. Here 1 means 1. So there is a naught into y is equal to q of x. Suppose in this format, if you see the equation in this format, if the order is n, means the power of x is n. If the order is n minus 1, means the power of x is n minus 1. If the order is 1, means here the power of x will be 1. So if you see any of this function in this format, then how to do the simplification? Suppose I am going to assume small x is equal to e to the power of t. I am going to assume small x is equal to e to the power of t. Then I want to do the differentiation. Then I am going to get here, see here, I am going to get in this format, which is x into dy by dx is equal to, here order is 1, means power is also 1. So x into dy by dx is equal to theta into y. The theta is called as the d by d theta, d by dt. So the theta is called as the d by dt. Suppose x square d square y by dx square will become theta into theta minus 1 into y. If you want x cube into d cube y by dx cube is equal to theta into theta minus 1 into theta minus 2 into y. So now replace these things in the above original equation and do the simplification, means you are going to get in terms of t only we are going to get. So therefore now substitute all this in the above main equation, then we get in this format, which is f of theta into y is equal to p of t. Some function of t, means I am going to assume just p of t. So now get y and last put t is equal to log x base c. So now we have to solve this equation. Now solve this equation and get the complementary solution and also the particular integral solution, and finally find the final solution, replace t. So take the log on both sides, logarithm base c, then finally you are going to get t is equal to log base x with a log x with a base of e. So replace t is equal to log x base c in the final solution, then you are going to get the solution for this equation. So the only thing is, if the degree is n, if the order is n, means if the power of x is also n, means if the degree of the differential equation and the power of x, if both are same, then then adopt this method to reduce into the equations whatever we have learned. Means replace x is equal to e to the power of t, means x into dy by dx is equal to theta into y, x square into d square y by dx square is equal to theta into theta minus 1 into y, x cube into d cube y by dx cube is equal to theta into theta minus 1 into theta minus 2 into y. So now you are going to get in this format, which is f of theta into y is equal to p of t. This equation which you can solve by using any of the previous methods, and final solution, replace t is equal to log x base c, and then you are going to get the actual solution for this differential equation. To get the solution of the differential equation, that differential equation is depending upon only one variable. But now we are going to discuss about the partial differentiation. Means if whenever the output is a function of so many variables, then how to get the solution of any partial differential equation, how to get the solutions, that we are going to discuss now. See, I have already told you, which is you have to remember these three things, which is p, q, r, s, t, where p is the partial differential with respect to x, and q is a partial differential with respect to y, and r is partial differentiation with respect to x square, means 2 times do the differentiation, whereas s means do the partial differentiation with respect to x and y, and t is partial differentiation with respect to y square. So p, q, r, s, t, x, y, x square, xy and y square. It is a easy way to remember. Now we are going to see the different ways by which we can get the solution of a partial differential equation. See, there is a first method. The first method is called as a by direct integration. Step by step integrating form a solution. So this is called as a by direct integration, means we can easily separate them individually and do the integration, and then we are going to get the general solution. It is like a variable separable method only. This all are independent of each other, so you can do it in a very easy manner. Suppose if the second is a linear partial differential equation of first order. So now we'll discuss the how to solve the linear partial differentiation equation of first order. Suppose this is capital P into small p plus capital Q into small q is equal to R capital R, where small p is equal to dou z by dou x and the small q is equal to dou z by dou y. I've already told you these things. Where capital B, capital Q, capital R are the functions of x, y, z, because it is a function of more than two variables. So therefore x, y, z. So how to solve the solution I am going to get you. So now I am going to tell you how to get the solution, which is first thing is you have to go for the dx by capital P is equal to dy by capital Q is equal to dz by capital R. So like these things you have to do this one. So now I am going to take the first two terms I am going to equate, which is dx by capital P is equal to dy by capital Q. So integrate this and get a solution. So if I do the integration of this one, finally I am going to get some solution which is u is equal to a. Now I am going to equate this remaining first and third, then I am going to get dx by capital P is equal to dz by capital R. So now integrate this and we are going to get a solution which is in the format of v is equal to b. So now these two are the solutions. I can write a solution of either of this format, which is f1 of u comma v is equal to 0, or u is f2 is a function of v and v is a function of u. So all these three are eligible for a solution. So after getting this one, you can write a solution in the format of f1 function of u comma v is equal to 0, or u is a function of f2 of v, whereas v is a function of u. So you can write any of these three formats because anyone is the general solution of this partial differential equation. So if you see any partial differentiation of this format, capital P into small p plus capital Q into small q plus is equal to R, then the first thing is where small p is equal to dz by dou x and small q is equal to dou z by dou y. So therefore you are doing this process, which is dx by capital P is equal to dz by dy by capital Q is equal to dz by capital R. So equate first two and we are going to get a solution of format u is equal to a, and equate first and third we are going to get a solution of v comma b. So solution can be of either of this format, which is u comma f of u comma v is equal to 0, or u is equal to f2 of v, or v is equal to f3 of u. You can write any of this solution you are going to get. There is a non-linear, the third method is the non-linear partial differential equation of first order. Suppose if you see a non-linear partial differential equation of first order, how to figure out the solution now we are going to discuss. Suppose this is f of p comma q is equal to 0, means there is no variables like x comma y comma z, means there is nothing like x comma y comma z, only it's a function of purely function of p comma q is equal to 0, where small p is equal to dou z by dou x, small q is equal to dou z by dou y. Then solution will be, the general solution of this equation will be z is equal to x plus dy plus c. This is called as the general solution of this partial differential equation, which is z is equal to x plus dy plus c. Now what we have to do is, now here f of a comma b is equal to 0. F of a comma b is equal to 0 means replace p by a, replace q by b, means replace p by a and replace q by b. So now get a relation between a and b and then keep in our solution. So therefore you can see clearly here what we are going to do is, the first thing is here the general solution of this partial differential equation is, which is z is equal to x plus dy plus c. But here replace p by a and replace q by b. So therefore f of a comma b is equal to 0. So now you are going to get a relation of a comma b. So therefore suppose if I get a relation a is equal to some relation of b, substitute here in this above equation, then you are going to get a equation in terms of only two variables, either a or c or b or c. This is called as the general solution of this partial differential equation. Suppose there is another equation in this format, which is f of z comma p comma q is equal to 0, free from xy terms. There is nothing like xy, only there are z, p, q. If there is only p, q, means this is the format. Suppose if there is p, q with z, but there is no xy terms, then you have to follow this below procedure, which is, let I am going to assume x plus ay. Let I am going to assume u is equal to x plus ay. Now what we have to do is, here f of z comma, replace p by dou z by dou u, and replace q by a into dou z by dou u. So listen carefully here. It's a function of x z comma p comma q is equal to 0, means free from x comma y. Then we have to assume u is equal to x plus ay. We have to assume u is equal to x plus ay and replace z by z, p by dou z by dou u, and replace q by a into dou z by dou u is equal to 0, and integrate this, and at last keep u is equal to x plus ay. So now by substituting these variables, you are going to get some solution. After integrating, finally you have to replace u by x plus ay, and now you will get the general solution. See, listen carefully. See, you have assumed that u is equal to x plus ay, so you did the integration, and finally you have to replace u is equal to x plus ay to get the actual solution. The third case, see, if f of p comma x is equal to g of q comma y. So if you see any function in this format, which is p and x and q and y, then what we have to do is, we have to assume f of p comma x is equal to g of q comma y is equal to some function a. So I am assuming these two is equal. So therefore f of p comma x is equal to a and g of q comma y is equal to a. So if you solve this one, we are going to get p as a function of x, and if you solve this one, we are going to get q as a function of y. So therefore now, and if we rearrange this one, we are going to get in this format, and if you rearrange this one, we are going to get this format. So therefore general format, which is dz is equal to p into dx plus q into dy. But we know the value of p, we know the value of q, substitute here. So therefore dz is equal to p into dx plus q into dy, means dz is equal to f1 of x into dx plus g1 of y into dy. So now here you can see clearly, this is x, this is also x, this is y, this is also y. So now do the integration and get the solution. This is in the terms of variable separable. So therefore do the integration and we are going to get the solution. So therefore we can say simply that here, whenever in this format you have to equate to a, and you have to do this one, you have to do this one, and this is a function of x, this is a function of y. So in function of y, so use this procedure. So these are the three different cases in this overall case. Let me repeat this one again here, so that it will be very easier. So in the third method, there are three conditions. Suppose if f of p comma q is equal to 0, means there is nothing like x, y, z, then you have to, the solution is equal to z is equal to x plus by plus c, means replace p by a and q by b and get a relation across a and b and replace in the solution. So therefore you are going to get a solution with only two variables. Suppose if there is an equation of f of z comma p comma q is equal to 0, means this is a free from xy terms, then you have to assume u is equal to x plus ay, then replace z by z and p by dou z by dou u and replace q by a into dou z by dou u and get a solution and integrate, finally plus u is equal to x plus ay to get the actual solution. Suppose if you see any partial differential equation in this format, which is f of p comma x is equal to g of q comma y, then you have to equate to a and you have to equate this first and third and second and third. And if you rearrange this one, we are going to get p is equal to f1 of x and q is equal to g1 of y. So therefore the solution will be dz is equal to py into dx plus q into gy. But p is nothing but f1 of x and q is nothing but g1 of y, and do the partial or do the integration and get the solution, because there is a variable separable, because x and x, y and y will get the solution of this partial differential equation. Suppose this is the last equation we are going to see. Suppose z is equal to px plus qy plus f of p comma q. So you can see clearly here p is called as the dou z by dou x, q is called as the dou z by dou y. So you can see clearly z is a function of p into x plus q into y plus f of p. So therefore means this is called as a Clarion's form. This is called as the Clarion's form. So if you want to figure out the general solution of this partial differential equation, replace p by a and replace q by b. Then you are going to get z is equal to x plus by is plus f of a comma b. This is called as a perfect solution, or we can call this as a general solution of this partial differential equation. So if you see any partial differential equation of this format, which is z is equal to px plus qy plus f of p comma q, then this is called as the Clarion's form. So therefore replace p by a and q by b, then you are going to get this called as the general solution of this partial differential equation, or this format is called as a Clarion's form. So now we are going to learn about the other thing, which is the law of growth. See, law of growth and law of decay we are going to study now. So the rate of change amount of a substance with respect to time is directly proportional to the amount of substance present. Means the rate of change of amount of a substance with respect to time is directly proportional to the amount of substance present. Means the rate of change of a substance is directly proportional to the substance itself. So therefore dx by dt is directly proportional to x. Then I want to remove the proportionality constant, so therefore I have to place a constant value. So therefore dx by dt is equal to k into x. Where k is greater than 0, so therefore this slope is always positive, means this goes on increases. So if you solve this one by using we already know the different methods to solve this this differential equation. So therefore finally we are going to get x is equal to c into e to the power of kt. So you can solve this one by any of the previous methods, whatever we have learned, and then we are going to get this formula, which is x is equal to c into e to the power of kt. If you want to know what is the law of decay, the rate of change amount of a substance with respect to time is directly proportional to the amount of substance present. Means now it is going to get decay. So dx by dt is directly proportional to minus of x. So therefore dx by dt is equal to, if you remove the proportionality constant, we are going to get minus k into x, where k is greater than 0. So if you do the solution of this general equation, we are going to get x is equal to c into e to the power of minus kt. So this is the solution of this one. Means this is a decay and the above one is the exponentially increasing. So now finding the particular integral when f of x is anything. Suppose this is general format I am going to discuss now. Suppose yp is equal to f of x by f of d. Suppose if f of x is any format, if it is any format, but we have learned only some of the few basic. Suppose if the input is of different of some basic things only, we have learned the how to figure out the yp. Suppose if it is any other thing, suppose it's any random, then how to figure out the yp, now we are going to learn. See, suppose now I am going to make this f of d in the terms of in this format, which is d minus m1 into d minus m2 into, suppose I am going to assume there are n roots, means it is an algebraic equation, so I can make in the terms of m roots, so as n roots. So therefore now yp is equal to, I am going to split this into, by using the fractions I am going to split this in terms of this one. So therefore finally I am going to get a1 by d minus m1 plus a2 by d minus m2 plus a3 by, in this format, up to an by d minus m1. Means I have made the just a simplification of this into in this formats into f of x. So now what I am going to do is, now I want to, what is the value of yp is equal to, now a1 into e to the power of m1x into integral of f of x into e to the power of minus m1x into dx. And similarly here up to goes on an into e to the power of m1x into integral of f of x into e to the power of minus mn x into dx. So you have to follow this procedure in order to get the value of the yp. So a1 into e to the power of m1x into f of x into e to the power of minus m1 x into dx. So you have to go for all this procedure for each and every element, and finally you are going to get the yp is called as a particular integral solution of this for this f of x as the input. So now we'll discuss some of the important points here. See, y is equal to mx is called as a straight line because it is passing through origin for all the time. So it is nothing but a straight line. But x into y is equal to c, this is called as a rectangular hyperbola. I have already told you, I have already discussed about the rectangular hyperbola also. But y square minus x square is equal to x square, this is called as just an hyperbola. Whereas x square plus y square is equal to r square is called as a circle. So these are the general formats of a circle, hyperbola, rectangular hyperbola, and a straight line. Means y is equal to mx means a straight line, and xy is equal to c is called as a rectangular hyperbola, and y square minus x square is equal to x square is called as a just an hyperbola, and x square plus y square is equal to r square is called as a circle. We need to form the partial differential equation by removing the arbitrary constants. See, the thing is, we need to form the partial differential equation by removing the arbitrary constants. See, suppose if you know the general equation, so from the general equation there will be a constants. So you have to remove these constants, and then you are going to get a partial differential equation. Suppose capital A into dou square z by dou x square plus capital B into dou square z by dou x into dou y plus capital C into dou square z by dou y square is equal to f of x comma y comma z comma p comma q. See, this is an algebraic equation, means we can say it is a partial differential equation. So if you see any partial differential equation in this format, which is a into dou square z by dou x square plus b into dou square z by dou x into dou y plus c into dou square z by dou y square is equal to f of x comma y comma z comma p comma q. So if you see any partial differential equation in this format, then you need to know these conditions. You have to see these conditions. Suppose b square minus 4ac is equal to 0, then this general solution will be in the parabolic form. If b square minus 4ac less than 0, then the general solution of this partial differential equation will be in the ellipse form. If b square minus 4ac greater than 0, then the general solution of this partial differential equation will be in the hyperbola. Is equal to means parabola, less than means it is an ellipse, greater than means it is a hyperbola. So is equal to means it is a parabola, less than means it is a ellipse, and if it is a greater than means it is a hyperbola. So therefore j into dou square z by dou x square plus b into dou square z by dou x into dou y plus c into dou square z by dou y square is equal to function of f of x comma y comma z comma p comma q. Then b square minus 4ac is equal to 0 means the general solution of this partial differential equation will be in the parabolic form. Whenever b square minus 4ac less than 0 means the general solution of this partial differential equation will be in the format of ellipse, whereas b square minus 4ac greater than 0 means the general solution of this partial differential equation will be in the format of the hyperbola. Dou square by dou x into dou y is equal to dou square by dou x into x dx means the way you are doing the partial differentiation is independent the way you are going to do. See, volume of a sphere is 4 by 3 pi r cube. See, a sphere of radius r, then the volume is equal to 4 by 3 pi r cube. But if you want to know what is the surface area of a sphere, which is 4 pi r square. See, now d theta by dt is equal to minus k into d theta minus theta naught. See, this is called as a Newton's law of cooling. The theta is called as a body temperature and theta naught is called as the outside temperature. So d theta by dt is equal to minus of theta minus theta naught into k. So therefore d theta by dt is equal to minus k into theta minus theta naught. This is called as the Newton's law of cooling equation, where theta naught is called as the outside temperature. It's a constant value. The theta is called as a variable body temperature. Means this is going to change with respect to the outside temperature. So therefore if you solve this one, we are going to get theta is equal to theta naught plus c into e to the power of minus kt. So you can solve this equation with any of the methods we know. So therefore finally you are going to get theta is equal to theta naught plus c into e to the power of minus kt. So this is called as a Newton's law of equation, which is d theta by dt is equal to minus k into theta minus theta naught. This is called as a Newton's law of cooling, where theta is called as the body temperature and theta is called as the outside temperature, and outside temperature is a constant value, but the top body temperature is going to change with respect to time. So therefore final solution will be theta is equal to theta naught plus c into e to the power of minus kt. D square is nothing but here, if d square is equal to minus 1, suppose if d square is equal to minus 1, then d is nothing but it will be equal to plus or minus i1, because root over minus 1 is called as I, so it can be either plus I or minus I. See, cos of root 3, see always, suppose root 3 is nothing but it is you have to keep in the radian mode. See, always root 3 is nothing but you have to keep in the radian mode, and you will get a solution which is called as the minus 0.16. See, x by a whole square plus y by b whole square is equal to 1. This is called as a ellipse format, or we can say equation of ellipse, whenever a is not equal to b. If a is equal to b, we are going to get a circle. So therefore y is equal to 6, this is called as the equation of straight line, and x into y is equal to c is called as the hyperbola. Y square minus x square is equal to c square, this is called as the ellipse, or this is called as a hyperbola, and this is called as the rectangular hyperbola, and this is just a hyperbola, and x square plus y square is equal to c square, this is called as the equation of circle. See, if you want to know what is the e to the power of lmx, means nothing but this is also log x base c. So e cancels, we are going to get answer x. So x into d square x by dt square, if this present, then it leads to non-linear differential equation. Suppose this is x, this is also x. So this is also depending with respect to time. and this is also with respect to time. So therefore we are going to call this as the non-linear differential equation. In order to be a linear differential equation, all the coefficients should be a constant value, but this x is depending on time. So therefore we are going to call this as the non-linear differential equation. Always the coefficient constant value, then only we are going to call it as the constant coefficient differential equation. Otherwise it is a non-linear. Suppose there is an example, dy by dx plus yx is equal to the power of minus x. So you can see clearly, this is, if you see clearly here, there is linear non-homogeneous differential equation, because non-homogeneous means input is there, so it is called as a non-homogeneous. Now we have to see whether it is a linear or non-linear. See here, the coefficient of dy by dx is 1, whereas y is x, but there is no differentiation, so therefore we can say here this is a constant non-homogeneous differential equation, because there is nothing like any variable term across the differentiation. So that is the reason we are going to call it as a linear, and but it is a non-homogeneous means input is not equal to 0. So therefore we are going to call this as the linear non-homogeneous differential equation, because for differentiation the coefficients are constant value. So because of that only we are going to call it as the linear format. See, 1 by d is nothing but d is called differentiation, so 1 by d will be 1 integral. 1 by d square will be 2 times of integration. Sin 3 means you have to keep it radian mode to get the answer. But if you want to know what is the integration of f dash of x by f of x dx, then what we are going to assume is, let me assume f of x is equal to t. So therefore f dash of x into dx is equal to dt. So therefore integration of dt by t is nothing but log n t. T is equal to f of x. So therefore ln of f of x plus t is the solution of the integration of f dash of x by f of x into dx. See, now force is equal to mass into acceleration, or simply we can say F is equal to m into dv by dt. So dv by dt is called as the acceleration. So now I want to write dv. So dv is equal to by m into dt. So now I want to do the integration. So therefore initial velocity to the final velocity is equal to initial time to final time into f by m into dt. So therefore you are doing the integration from initial velocity to final velocity. So here also time should be initial time to final time. So you are going to get a equation in this format. So for a pendulum, the time period is equal to t is equal to 2 pi root over L by G. So now I want to do the differentiation with respect to length. So therefore dt by dl is equal to, so dt by dl is equal to, so root is a constant value, so 2 by root g into, so if you do the differentiation with respect to L, you are going to get 1 by 2 into under root over L. So dt by dl is equal to t by 2L. So now if I take t in this format in the downward, so I am going to get dt by t is equal to dl by 2L. So this is also one more important equation, because on these equations the questions are being asked. Now integration of x is equal to 0 to 2 pi sin x dx is equal to 0, because always for 0 to pi there will be positive area, and pi to 2 pi there will be negative area. So overall area will be 0. So therefore by integration or numerical in method, see, by both methods, whether you go for the absolute method or whether you go for the numerical method. See, numerical method is also called as the absolute method. By this method is called as the exact method. So either you go for integration method or the numerical method, both you are going to get the same result. See, m into dx plus n into dy is equal to 0. It is said to be exact. I have already told you this equation is exact when dou m by dou y is equal to dou n by dou x. Then only we said this is the exact equation. Then I have already told you what is the general format of getting the general solution of this differential equation also we have discussed, which is you have to do integration with respect to x treating y as constant, but for this one we have to assume x is equal to 0, then whatever the equation we are going to get finally, that you have to do with the integration with respect to y. Suppose if a function y is equal to f of x as extremum at a certain point x0, that extremum can be either a positive, whether it can be maximum or minimum. So therefore at this maximum or minimum, definitely their slope's value will be always equal to 0. So therefore dy by dx at that particular extremum, there will be a maximum or minimum point, always its slope value will be equal to 0. Slope means dy by dx. So now derivative of x into y is equal to, you can write either in this format, which is x into dy plus y into dx. So derivative of x into y is equal to x into dy plus y into dx. But if you want to know derivative of x by y, which is dx into y minus x into dy by y square, and derivative of y by x is equal to dy into x minus y into dx by x square. So this is the basic formulas, which is u into v whole derivative is equal to u derivative v plus uv derivative, and similarly derivative of u by v is equal to u derivative v minus uv derivative by v square. So you can use this above formulas to get this ones. So now for nth order differential equation we get n arbitrary constants. So for nth order differential equation we get n arbitrary constants in its general solution and n initial conditions required to get that arbitrary constants. So if you take nth order differential equation, definitely in the differential equation you are going to get the n constants. So if you want the n constants, definitely you need the n initial conditions. That is the meaning of this one. Equations of the form dy by dx is equal to f of x plus dy plus c can be reduced to the variable separable form by putting ax plus dy plus c is equal to t. Suppose if you see a differential equation of this format, which is dy by dx is equal to f of x plus dy plus c, then you can assume dy plus c is equal to t and do the simplification. It is nothing but you can replace this in terms of the variable separable form, and then you can do it integration separately and you can get the solution. Suppose if m into dx plus n into dy is equal to 0, if dou m by dou y is not equal to dou n by dou x, means we can say this is not the exact differential equation. If it is not an exact differential equation, how we need to proceed? How we need to proceed to get the solution? Which is, I am going to assume which is p is equal to the difference of this one, which is dou m by dou y minus dou n by dou x. I am going to assume the difference of these things by, I am going to take the next value, which is n, this value n. So if I do these things, it will be a function of x only. So if I do this simplification, I am going to get it's a function of x only. Therefore, the integration factor is equal to e into integral of p dx. Then multiply this to the main equation and it will become exact equation. See, now what we have to do is, now you have to take the p. P is equal to different of this by n. So now it will be a function of x only. So if the function of x only means the integration factor will be e to the power of integration of p dx. See, whatever the value you are going to get, thus you have to multiply by both the things. On the both side we need to multiply. And then now the equation will be exact. So you can use the above procedure, the previous method, you can get the solution in an easy manner. You can go for another process also. See, whether you can go for the reverse process. If you go for the reverse process, which is dou n by dou x minus dou n by dou y, then you have to go for this one m. See, whatever the term which is going to present, the term you have to take here. Now it will be the function of y only. See, if it's a q, I am going to assume it's a q. So therefore you have to go for integration factor, which is e to the power of integration of q into dy, because q is a function of y, but previously p is a function of x. So therefore I have taken the x there. So multiply this to the main equation and now it will become exact. So only thing is you have to assume p or q in such a manner, always the equation will be always in an exact manner. Then you can easily go to the previous original method to get the solution. In an electric field, the paths along which current flows are the orthogonal trajectories of the equipotential curves and vice versa. I have already told you in the EMT subject, always the electric fields and also the potential equipotential graphs are always orthogonal to each other. Then only we can say equipotential curves means at each and every point on that curve the potential is same. So therefore that is the reason we are going to call it as the equipotential curves. Always the equipotential curves and the electric fields are perpendicular or orthogonal to each other. Fluid flow, the streamlines and the equipotential lines are orthogonal trajectories. Even in the fluid flow, also we are going to see that the streamlines and the equipotential lines are orthogonal trajectories. The procedure to find the orthogonal trajectory of polar curves. See, I have told you regarding how to find the orthogonal trajectory of a dimensional, or you can say the coordinate system. But if it is given in a polar format, how to figure out the orthogonal trajectory, now we are going to discuss. So suppose this is a curve which is in the polar format. They have given the curve which is r is equal to f of theta comma a comma n, where a is a constant. Then remove the constant a by performing dr by d theta to the given family of curve. So now what you have to do is you have to perform dr by d theta for this above equation, and by using these things we have to remove the value of constant a. Replace dr by d theta by minus r square d theta by dr. See, whatever the dr by theta you have got, now replace this thing by minus r square d theta by dr, and then integrate the obtained new equation. So then we have to integrate the obtained new equation to get the family of curves which are orthogonal to this curve. So therefore this is the way that you have to do. So first do dr by d theta to remove the constant a and replace dr by d theta by minus r square d theta by dr. Then you are do the integration to get the family of curves which are orthogonal to these curves. See, 1 by d minus a into f of this value I have already told you, which is e to the power of ax into integral of f of x into e to the power of minus x into dx. This value I have already discussed, which is 1 by d minus a into f of x is equal to e to the power of ax into integral of f of x into e to the power of minus ax into dx. This is the way that you have to go for the in order to figure out the particular integral solution. I already discussed this point. So we have successfully completed all the formulas which are very much important of the differential equations for the GATE examinations and also IS and some of the state examinations like the GENCO, TRANSCO. In this also they are going to ask the mathematics portion. So this formula reason is very much useful to solve this type of questions. I hope you like the content of our channel. If you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever you upload a new video, the direct notifications comes on mobile. If any improvements here in our video lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.